Scaling AI shouldn't mean losing control. Today, AI agents and LLMs require access to your most sensitive data. How can you provide that access without compromising security, compliance, or your intellectual property? This challenge affects any organization handling sensitive data. SuperSwarm is the answer. It is a confidential execution layer that runs across existing clouds, on-premise infrastructure, or as a seamless hybrid. Swarm gives you the privacy of your own data center with the elastic scale of the cloud. You can run any complex workloads. Your data and models are not accessible to infrastructure providers or platform operators. Traditional cloud operators require you to trust them not to misuse or steal your data. We replace blind trust with cryptographic verification. Let's deploy an LLM within the SuperSwarm workspace and prove its privacy in a truly self-sovereign environment.
This is a Swarm cloud environment. For this demonstration, we are running several nodes in a single data center in Warsaw. Each node is a confidential virtual machine running within a trusted execution environment. If you add more nodes, Swarm scales and organizes automatically. There is no centralized scaling bottleneck. First, we log into our personal workspace using one of the various available methods. Let's create a new cluster, allocate additional memory, and attach a GPU to support AI workloads. The Swarm protocol automatically selects the best-suited nodes according to our requirements. With the cluster ready, we download the kubeconfig file, which provides secure access to the Kubernetes environment. For this deployment, we use a script that deploys Ollama and launches an LLM within the cluster. Let's apply the configuration and create the Kubernetes resources. Ollama starts first, followed by the web UI. Within a couple of minutes, all pods are up and running. At this point, the application is operational inside the cluster, but not yet publicly accessible. To make it available externally, we publish the cluster. The platform freezes the runtime configuration and forms deployment evidence, a cryptographically verifiable execution report. Before the service becomes publicly reachable, we verify domain ownership by adding a DNST-XT record. This standard mechanism ensures that no one can bind a domain they do not control. Domain verification is performed only once. Future redeployments do not require repeating this step. Once the domain is verified, the application becomes accessible. Let's open the LLM's web UI running inside Swarm. Let us confirm that the model responds. And, as expected, it does. For user verification, we have a special browser extension. It verifies and displays the deployment evidence, a signed report that describes the application's runtime configuration and confirms that it was launched within the confidential environment. Here, we can see the deployment structure and all the details necessary to establish trust in the application. Users can independently verify how the application was launched by examining container image hashes, configuration parameters, and all components that define the runtime environment. Swarm generated this report when the cluster space was published. If the application is exposed externally, Swarm provisions a TLS certificate for its public hostname. This certificate's private key never leaves the confidential environment. Swarm then cryptographically links that certificate to the verified deployment. Let's compare the certificate fingerprint shown in the browser with the fingerprint in the report. They match, confirming that this public URL is bound to the exact runtime configuration running within the confidential environment. This creates a verifiable trust chain between the public application URL and the confidential environment. Only this specific deployment can produce this specific certificate. If the user unpublishes the application, the certificate is revoked. And if the configuration changes and the application is published again, a new certificate and new evidence are generated. In addition to the web UI, the model is also accessible via API. To securely connect to it, we use the gatekeeper, a verification proxy for confidential services. Let's create a router, assign it a local port, define the destination, and specify which deployment evidence we trust. Once started, the gatekeeper verifies the deployment before allowing traffic. Now, we can integrate the model directly into development tools. For example, in an IDE, we configure a llama to use the local port exposed by the gatekeeper. The connection is verified successfully. From this point on, the LLM running inside the confidential SWORM cluster behaves like a local model, but with hardware-backed confidentiality and cryptographic verification. Let's send a test prompt and ensure that the model responds. All traffic passing through the gatekeeper is monitored and accounted for. Here, you can see how confidential services are accessed. In this demonstration, the traffic volume is minimal, so the graph remains nearly flat. SuperSwarm provides a secure and verifiable way to run AI agents, databases, and other complex workloads. Everything is verified algorithmically without human interaction. You do not have to trust centralized authorities or individual node operators. Instead, everything is backed by confidential computing, cryptographic verification, and open-source code. You stay in control over your data, regardless of the infrastructure. Super Protocol, making self-sovereign computing unstoppable.